So in this question बच्चों, a man start pulling the string at the rate of 4 meter per second. This means the man is start pulling the force. There is the acceleration of this rate is 4 meter per second square. That means the block is also going up with a is equal to 4 meter per second square. Yes or no? Yes or no? Yes or no? So this block is also going 4 meter per second square. So according to the free body diagram, according to the second law, Newton's second law, right now we are writing here equation. Okay. For finding the tension first, then work done by T is equal to 2 seconds. Work done. Okay. So for work done, we know that F into dx. But in this case, F is nothing but tension in the string. So firstly we find tension. Okay. How to find tension? There is a mg of this block downward, and there is a T. In which part the mg and T, which one is greater? T or mg? T or mg? T, right? Very good. So what we are writing here? T minus mg is equal to ma. So what is T? T is equal to mg plus ma, that is m into g plus f. Now g is 10, m is given to you 5, g is 10 and a is given to you 4. So this value is 70 Newton. So T comes out that T is equal to 70 Newton. That is also equal to F. Now second part is what is the displacement of this particle? If we pull the string this way, then the block is going upward, right? So what is the displacement? So for displacement we are using the equation of motion 1D plane. S equal to ut plus half at square. Now this initial velocity of particle is 0, so this part is 0. Why? Because initially block is at rest condition. Okay. So what is the displacement? Displacement is half into a is 4, and the time is that given in the question. The time is 2 seconds. Okay. So this is 2 square. That is how much this value is. This value is 8 meter. Yes. So if we finding the work done. The work done is equal to force into displacement. That is how much? That is 70 into this displacement 8. That is 756. That is 650 joule. This is the work done in this question. Is there any doubt to anyone?
No sir.
No sir. Okay, then fine. Thank you. So in this question, बच्चों, a man start pulling the string at the rate of 4 meter per second. This means the man is start pulling the force. There is the acceleration of this rate is 4 meter per second square. That means the block is also going up with a is equal to 4 meter per second square. Yes or no? Yes or no? Yes or no? So this block is also going 4 meter per second square. So according to the free body diagram, according to the second law, Newton's second law, right now we are writing here equation. Okay. For finding the tension first, then work done by T is equal to 2 seconds. Work done. Okay. So for work done, we know that F into dx. But in this case, F is nothing but tension in the string. So firstly we find tension. Okay. How to find tension? There is a mg of this block downward, and there is a T. In which part the mg and T, which one is greater? T or mg? T or mg? T, right? Very good. So what we are writing here? T minus mg is equal to ma. So what is T? T is equal to mg plus ma, that is m into g plus f. Now g is 10, m is given to you 5, g is 10 and a is given to you 4. So this value is 70 Newton. So T comes out that T is equal to 70 Newton. That is also equal to F. Now second part is what is the displacement of this particle? If we pull the string this way, then the block is going upward, right? So what is the displacement? So for displacement we are using the equation of motion 1D plane. S equal to ut plus half at square. Now this initial velocity of particle is 0, so this part is 0. Why? Because initially block is at rest condition. Okay. So what is the displacement? Displacement is half into a is 4, and the time is that given in the question. The time is 2 seconds. Okay. So this is 2 square. That is how much this value is. This value is 8 meter. Yes. So if we finding the work done, the work done is equal to force into displacement. That is how much? That is 70 into this displacement 8. That is 756. Is there any doubt to anyone?
No, sir.
No, sir. Okay, then fine. Thank you. So, dear student, in this question, the question says that a block of mass 5 kg, with this block having mass 5 kg, which is sliding down on a smooth inclined plane. What is smooth inclined plane? According to smooth inclined plane, we know that there is no friction. So, there is a friction is equal to 0. Friction force equal to 0 in this case. So, the block is sliding down by the force which is only the component of mg which is acting towards downward to the block. That is the only force which is acting on the block here. There is no friction. That and the plane as shown in figure, arranged near the bottom of the inclined plane. There is a plane inclined kept on the bottom of the wedge where this is the k, and k having value is that is given here 600 Nm. That is 600 Newton meter. This is the value of k. Okay. So find the compression of spring at the moment when the velocity of block is maximum. So when the block is coming downward, at that time the velocity is maximum, and when the first time when the block strike on the spring, that is the maximum velocity of the block. Is this okay or not? Yes, no? Fine. So if we are talking about the component of this thing, so there is a mg downward, okay, and this is the mg cos theta, this is the theta, and this is mg sin theta. There is a upward force, that is Newton, and F equal to mg sin theta, and this force is equal to the spring force which is kx. So we have to find here in this case, when the first time the block is strike on the spring, then the spring compresses what displacement? Matlab, when the block is strike on this spring, then at what x spring is compressed downward. So this thing we have to find here. So this is simple. When the block is strike with this velocity, then the spring force is applied there on the block. That is, the spring force is equal to the mg sin theta. So from by FBD, we know that F spring is equal to mg sin theta. Is this okay or not? Clear again? Okay, fine. So the spring force we know that is the minus kx is equal to mg sin theta. So this is the x. So x equal to how much? Mg sin theta minus mg sin theta by k. This is the formula. If we solve by the putting value of mg sin theta here by k, then we got the answer here. Now, according to question, the mass is given to you 5 kg. So we are writing here 5 into 10. Now cos 37 is how much? 3 by 5. Cos 37 is 3 by 5 because we know this triangle now. So this is 53, that is 5 and 3. This is 37, that is 4. So cos 37 is 3 by 5. Sin 37 is 3 by 5. Okay. So this value is 2 and the k is 600. Okay. 5 into 10 is so this value is how much? 10 into 3, 30. 30 by 600. So this is cancelled out. This is how much? 20. So 1 upon 20 meter per second. But in the question they say that the spring force in centimeter. So if you find in centimeter, then what we are doing? We are multiplying by 100. So if we multiply by 100, 1 upon 20, 20 into 100. So we got 5 centimeter. 5, sorry, this is a centimeter. Not this is only meter. Not unit is a unit of x is only in meter, not meter per second. So the value of this is, the value of x is what? That is a 5 centimeter, and the x sign is denoted here, that is minus x is equal to 5 centimeter. This x sign denoted here, spring is compressed backward. So this sign is shows that spring is compressed. There is a compression. Okay, that's all about this question. So in this question says that a particle of mass m attached with a horizontal string describe a circular radius r on the rough horizontal table. Suppose that there is a table. In that table, a particle is attached, mass m, this is the center, and particle is rotating in a circle. In this case, and they say that after complete one round, one full trip means displacement is 2 pi, distance is 2 pi r, not displacement. The distance is 2 pi r. Now, round of the circle, the speed of particle is half, means the initial speed of V initial of particle is V naught and V final particle is V naught by 2. Okay. Now, if what is the coefficient of friction? Coefficient of friction pressure means definitely there is a friction force applied on the particle, that is kinetic friction. So according to this data, the one thing comes in my mind firstly, so that we solve this question with the help of work energy theorem, because there is a kinetic and final energy given. So we easily find the work energy theorem. By the help of work energy theorem, we easily find the value of mu. So if we are talking about this question, so we understand that there is only one force acting on the particle, which is mentioned in the question, that is friction force in the back part of the this system. So if we are talking about the work done is equal to F final minus K final minus K initial. So what is work done here? Work done is the friction force, that is mu n into 2 pi r, that is the displacement of the particle, which is for the one round. Okay, this is given in the question already. So if we are talking about the K final and K initial, so what is K final? K final is half m, and this is that the velocity is like V naught upon 2 in this case. So this is V naught by 2 square minus initial velocity is half m V naught square. So if we talking about this part, so this part is the mu is equal to n is equal to mg in this case. So if you modify this equation, so mu mg into 2 pi r is equal to half m is common. Here is v square by 4 minus v square. So if we multiply solving this while taking the LCM here, so we show that there is a 3, okay, where there is a 3 v naught square by 4, right? So what we are doing here, mu is equal to m, okay. In this case we also cancel m and m, okay. So mu g into 2 pi r is equal to, this value is 3 v naught square by minus 3 v naught square by 8. This is the value. So if we divide all this value there, because we in the question they find the value of mu here only. So if we divide this part, then the mu is 3 v naught square by 8 pi g r. So that 8 to the 16, that value is 16 by g r. So this is the value of mu, which is option number first. So option number first is the correct answer according to the question, and we are easily find by the help of work energy theorem the value of mu. Okay, so thank you. Friend, today we learned about work energy theorem, and I show you how work energy theorem is very important for our numerical part. Okay, so according to work energy theorem statement, first statement is the work energy theorem says that work done by all forces acting on the particle is equal to change in kinetic energy. That is, work done is equal to delta K. What this means? This means that work done is equal to K final minus K initial. That is, work done is equal to half m V final square minus half m V initial square. This is the work energy theorem. But if we know from where this energy theorem is came from, I give you a support of like proof of this theorem, so that we learn about from where this theorem is came from. Suppose if we take an example, suppose for constant force F, example, that is proof also, right? So for constant force F, if we talking about if there is a one block of mass M moving with initial velocity u, and this block is moving with some displacement s. This is the final velocity of block when they reach to point s. Okay, and the block is moving from here. Now, if a force applied, continuously applied on the block mass m, and definitely if the force is applied on mass m, then block acceleration is a in this direction. So according to Newton's second law, if we say that F is equal to ma, so A is equal to F by m. From this law, now we know that the equation of motion, that is v square, right here, v square u square plus 2as. If we put this formula, the value of A from here to here, then we know that v square minus u square is equal to 2 into F by m, that is into s. So m is multiplied there. So m into v square minus u square is equal to 2fs. So this formula is mv square minus u square by 2, that is f into s. So we know that according to this work energy theorem, the theorem is also said that the final velocity means kinetic energy of the particle, final kinetic energy of the particle minus initial kinetic energy of the particle is equal to the work done. So from here also we clearly see that half mv square minus half m u square is equal to f into s, and this is nothing but fs is the work done, this is the initial kinetic energy, and this is the final kinetic energy. So from this part we clearly find that work done. So this is the proof of work done, proof of work energy theorem. That's all. Three identical particles are joined together as shown in figure. That means three identical particles, that is A, B and C, are joined in this case. Just all three particles are joined with string, right? And they all are moving in a horizontal plane, that is they all are moving this way with the velocity, angular velocity omega. And this is the center. This is the center of a string which is connected with O. If we are talking about the distance from the center between C is 3L, distance from B is 2L, and distance from A is L. Okay? So if we are talking about the tension in the string is T1, T2 and T3 is, then we easily find by the help of free body diagram. So one by one I draw the free body diagram of C, B and A accordingly, and then I get the value of tension, which is the answer. Now if you draw the FBD of C, so FBD of C में, this is the center and the C particle is there. So the outer, this is the T1. Suppose this is the tensor T1 in C, T2 in B, and T3 is A, T3 on A. So if you are talking about the tension on C part is, then there is the outward force, that is the centrifugal force, that is mv square by r or m omega square. If the particle moving with angular velocity omega, then we are taking the m omega square r, and the length is, that is 3m. So according to question, according to free body diagram, we write here m omega square r, where r is 3m. So T1 is equal to 3m omega square. This is the first equation. Now if we are talking about the free body diagram of particle B, so FBD of particle B. So according to this diagram, the particle B having tension T1 and T2 both, and the one centrifugal force acting, which is acted by B. So particle B and C, this is the T1 and this is the T2, where this is the center. So this is the 2L and this is the length 3L, which is mentioned in the question. We already know the value of T1 from equation 1. This is 3ml square. But if we talk about the particle 2, so the outer force is the centrifugal force of this is m omega square r again. So the value of T2 is equal to m omega square into 2l plus the T1 value, that is T2 is equal to m omega square r plus T1, that is T1 is equal to how much? T1 is equal to 3m omega square l. So the total value of this part is 5m omega square. So we got the value of T2 is 5m omega square. If you are talking about the particle A, means the block A which is connected on the string is, then we draw the free body diagram of A, FBD of A. That means this is the origin, this is the particle A, the length of the string is L only, okay, and this is the T2, which is already known that m omega square into 5l, right? And this is the centrifugal force by A. So if we are talking about the particle A, that means T3, that is T3 is equal to T2 plus m omega, T2 plus Fa, that is m omega square into 5L plus m omega square L, that is 6m omega square. So according to question, we get the all value, that is T1, T2, T3, that is m omega square 3m omega square L, that is T1 is to 5m omega square L is to 6m omega square L. So if you cut the m omega square L in all section, so we got 3 is to 5 is to 6 ratio is the answer. That is option number D is your correct answer. Okay? Any doubt, student? Fine. The three identical particles which is shown in the figure A, B and C, particles are joined together with the thread. Thread as shown in the figure, there is a thread, that is thread connected from point O to C, which is only one thread in which the particle A, B and C are connected. And the all particles having tension T1, T2 and T3, which are varying with according to the distance, because the mass is also reducing when we come from the C towards center. So if we draw the free body diagram, then we easily find the tension of T1, T2 and T3 in this question. So firstly we draw the free body diagram of FBD of C. So if you draw the FBD of C, we take the distance from center, that is 3L, because this is L and this is L. So we are talking about C. From the center, the distance of C is 3L. From the center, the distance of B is 2L, and from the center, the distance of A is L only. So accordingly, we take it here. Now, if we take the free body diagram of C, so there is a tension T1, and this outer force is the centrifugal force, that is mv square r or m omega square r. So we take an m omega square r here. So T1 value is nothing but m omega square, and the r is nothing but 3L. So we write here m omega square 3. So T1 value is m omega square 3L. If we are talking about the value of FBD particle B, so in case of particle B, the particle B having acting two forces, the two tangent, that is T1 and T2 both. So if we want to find the T2 here by the help of free body diagram, then particle B having T1 in this side and T2 in this side. So in this case, this is a string. So all T1 and T2 adding, matlab T1 and T2 both are adding here because there is a string, and a string having two mass. So if a string we increase the mass, then the tension of the string is addition of both masses. So if we are talking about T2, so T2 plus T1 is equal to what? So T1 is already we know that T1 is 3m omega square L. We already find here T1 value. But for T2, what we are doing from the center, this length is 2L. So for T2 is m, here one force also m omega square r, that is for T2. Okay, outward. So this is m omega square into 2L. So the total force is T2 is so in this question, they say that three identical particles are joined together. That means A, B and C are joined together with a string. And this is the center. This is having center in which the all particles moving in this way. If all particles moving in this way with omega, then they know that what is the tension of the string is. Suppose this is the tension T1, this is the tension T2, and this is the tension T3. According to question, they said that the thread as shown in figure, all of these particles are moving in a horizontal plane. All are moving in a horizontal circular motion. Okay. And the ratio of, they want in the question, the ratio of tension T1, T2 and T3. So if we draw the free body diagram of point C, B and A, then we can easily find the tensor in T1, T2 and T3. So firstly we draw FBD of C. So if I draw FBD of C, so in FBD of C, this is the length where if we are talking about from the origin to center C, the length is 3L. So if length is 3L, so we are writing here the outward force, which is the centrifugal force, that is pseudo force also, or centrifugal force, that is m omega square L, and this is the tension T1. So T1 is equal to m omega square L, and where L is 3L, so 3m omega square L. This is the, because L is 3m for this question, because this value is 3m. So we know that T1 value is 3m omega square L. Now if we are talking about the FBD of B particle, so if we are talking about B particle, so from origin the length of B is 2L, and there is a tension T1 and this is a tension T2. According to question, the tension T2 on B and tension T1 on C, which is hanging the block attaching the body C. Okay, so if you finding this one, now in this case the both, if we hang something with a block, then the two blocks are connected, and which are like shown in the figure, and we write here T2 plus T1 because there is a string, and the string connected with T3 block, so that we are taking the addition in, not subtraction in this case. So if we are talking about the T2, so what is the value of T2 is, firstly T2 is equal to m omega square into 2L, length is 2L, so 2m omega square, and we know that T1 is already known. T1 is already known, that is 3m omega square. So that is T2 is equal to 5m omega square. So this value is 5m omega square. T2 is 5m omega square. Okay. So in this question, the two particles P and Q are moving with velocity as shown in figure. Where the particle 1, suppose that this is a particle P, means velocity P is 10 meter per second and velocity B is what? Matlab in this question they want to know what is the velocity B. In this question they said that the angular velocity of the particle is 2 radian per second. So according to the formula of angular velocity, we know that angular velocity is velocity upon radius. Okay, in this part the radius of the particle where the particle rotates is 5 meter per second. Okay, so r is equal to 5 meter, radius is 5 meter, velocity, they want velocity, and we know the formula omega. So we take the component of this force, the component of Vb is Vp sin theta, and the component of this is Vp, sorry, not Vb, this is a Vq because point is Q, and this is a Vp is equal to Vp sin theta. So according to this question, we know that the formula for omega is equal to Vp sin 37 degree plus Vq sin 45 degree by R, capital R. So omega is equal to what is the formula? What is the value of Vp? Vp is 10 and the sin 37 is 3 by 5. Okay, and the value of this is omega is Vq and sin 45 is 1 by root 2 upon 5. This is 2, so this value is 6, and omega is already given 2 radian per second, which is mentioned in the question. Okay, so this is 2, this is 5 to the 10 minus this is 3 to the 6 is equal to Vq by root 2. So this value is 4 root 2 Vq. This is the answer. So first, the option number second is the answer.